Hello and welcome to today's lesson on displacement-time graphs. In today's lesson, we will first learn how these graphs provide a visual way to understand how an object's position changes over time. As with distance-time graphs, we'll explain the main features of these graphs. From this, we will learn that displacement can have negative values, unlike distance, which is always positive. Finally, we'll understand how to graph an object with constant velocity and an object moving away from or to the starting point. So far, we have learned the differences between speed and velocity and how to calculate them. We have also worked extensively with distance-time graphs. Building on this foundation, today's concept of displacement-time graphs will advance our understanding of physics by highlighting how position and direction are critical in analyzing motion. This deeper insight into vector quantities like displacement and velocity will enhance our grasp of motion in various contexts. Let's get started. Let's look at the main features of displacement-time graphs.
Are displacement-time graphs required for exams?
No, but they are valuable for appreciating the differences between speed and velocity and reinforcing the distinction between scalar and vector quantities. With this established, let's begin by understanding the axes of these graphs. Just like in distance-time graphs, the horizontal axis, x-axis, on a displacement-time graph shows time, usually in seconds. The vertical axis, y-axis, however, shows displacement, usually in meters. The key difference here is that displacement, unlike distance, is a vector quantity. This means it has both magnitude and direction. On a displacement-time graph, the displacement can have negative values. This is different from a distance-time graph, where the distance is always positive. Negative displacement values indicate motion in the opposite direction. The gradient, or slope, of a displacement-time graph represents velocity. Velocity is a vector quantity, meaning it includes both speed and direction. A positive gradient indicates that the object is moving in the positive direction, forward, and therefore has a positive velocity. A negative gradient indicates that the object is moving in the negative direction, backward, and has a negative velocity. Let's now consider some important cases of motion and how they would look on a displacement-time graph. Consider an object moving at a constant velocity of 2 meters per second in a straight line away from the starting point. The displacement-time graph for this motion will be a straight line with a positive gradient, reflecting the constant positive velocity. If the object returns to its starting point at the same velocity, the line on the graph will slope downwards, showing a negative gradient. This indicates that the object is moving in the opposite direction to return to its starting point. In today's lesson, we delved into displacement-time graphs within the context of velocity and the broader unit of forces. We began by understanding how these graphs visually represent an object's position over time, including the direction of motion. Unlike distance-time graphs, displacement-time graphs can show negative values on the vertical axis, indicating movement in the opposite direction from a chosen reference point. We learned that the gradient of the graph represents velocity, a vector quantity that includes both magnitude and direction. We saw how an object's motion at a constant velocity is depicted as a straight line with a consistent gradient, and how returning to the starting point is shown as a negative gradient. These insights helped differentiate displacement from distance and velocity from speed, emphasizing the importance of understanding vector quantities. Watch the rest of the GCSE physics course at Sophos Education.